All right, we're going to go ahead and start on one of these end bells. So I've got the plate chucked up in the forejaw here. I've not indicated anything yet. You can see we got run out there. So we're running out this way and the consistency of the center there. I want to point out that I'm not pushed up against the jaws there. If I was pushed up and I was trying to bump this around, it would make it really difficult. So I left it out so that I can bump this face nice and true on the plate. Let me get you closer, I'll show you what I mean. You see the gap there between the plate and the back of the jaw, that's what I mean. So that'll give me room there and get in here and bump this so that we can get the face of the end bell running nice and true. Since I got so much run out off of center, I'm going to go ahead and start with that bore and get it a lot closer, and then I can move on to the face. So I'm going to use my Starrett number 670 attachment. Let me hold it in a different position so it'll work. Very simple, easy way to indicate the idea of something. I just like using my big indicator, 1-inch travel indicators. All right, that's getting us pretty close right there. I'm going to go ahead and move on to the face. Looks like I'll have to move. Well, looks like I am out there on that. There's an area of this bore that hasn't been touched with the bearing, and that's what you can use to indicate it. But we'll also be verifying this register here where it's been machined. It's just a small area. It's hard to get into, especially on the face. And then there was one spot that I noticed some chatter, so the indicator might do some jumping as it's rolling across there. That's the reason why I got it kind of centered, so that whenever I indicate this face, it wasn't falling off there. 10, 20, about 25, 26. That ain't too bad for just sticking it in there and tightening the jaws. So we're going to look for our high, which is going to be over here. I think what I want to do is maybe get a bar and a better hammer to tap on this plate instead of trying to get in here with the nylon right there. All right, I got my brass bar that we can put in there, and we got the big boy Stanley that we can use. Let's see how this works right here. More good. Yep, a little bit too far. Let's see what we can do now. It's like 1.5. Not bad, right there. All right. Let's go ahead and we'll go back to this bore here and make sure that we're indicated in the center. All right, just on the inside of that bore there. And you can see, you can see right there just how far away we were. Let's see if we can split that little bit of wiggle there. We've got 1.5 to 2. That's the high. This is going to go low. Yeah, it's got a jump in there is what it's got. There's a little high spot. All right. What I'm going to do, I'm going to check the face again. I'm going to make sure we didn't move it around. And then I'm going to come in here and I'm going to check this counter bore and see if this is running true with that bearing bore there. That's just how this kind of work is. You got to work it back and forth until you get it running true. All right, not bad. We moved it 0.02. Let's go to the high. I did a whole lot right there. It's 1/1000. That's +2, 0, so that's about 2/1000 right there. That's not bad. You just want to kind of split it. So there's +3, 0. So I think that's going to work right there. These things are never perfectly round, but we just want to make sure that we're in the center there. We're in the center of this, so we are going to roll with it right where it's at. There's a shot of it spinning up. Looks good. Before I get started doing any machining, I was going to verify my mic, so I'm going to be using Granddad Starrett 2 to 3, and then I've got this Brown & Sharp 3 to number 4. That's a really nice mic. This was one that a viewer had given me a long time ago, and I just like it. It's a nice mic. So I'm using my Mitutoyo standards right here. We're going to use the 3-inch, and always make sure that everything's clean on the ends. And I like to just verify it whenever I'm doing these bearing fits, just to make sure that I'm going to be reading right, because I'm going to be reading into the tenths when I'm finished this thing. So I'm just running it up with my finger. You can use the thimble if you want to. It's on it. So that's good. We know that that one, this mic, that's why I always use it, because it always reads right on what it needs to. It's an old mic, but it was Granddad's. You can see his initials there and there. My dad used it for years, and now I've been using it for years. And it's Brown & Sharp. It always reads real good also. We'll come in here and do the same thing. And we're reading 0 on this one as well. Now, this is a good mic right here. I really like this Brown & Sharp. It's a good mic. All right, so there's our mics that we're going to be using. I'm also going to show you my chart there, and I'll be using my telescoping gauge to get my measurements there. All right, so here is the cast iron sleeve that we'll be pressing in there. This is what we're going to bore to finish. All right, and then our paper right here, it says 3.081 inches. That's going to be the diameter of the bore for this to press in there or shrink fit. I don't have liquid nitrogen, and I don't have any dry ice right now, so I'm just going to plan on pressing it in there. All right, and then going through some of my charts. So here is how I'm going to get my fit. If you look at 6207, it gives you, well, this is your shaft fit right there, but you have a maximum and minimum size. And then if you go across to this right here, so this is going to be your finish for a 6207 bearing, reading in inches. So 2.834.6 is going to be your minimum bore size. 2.8353 is going to be your maximum there. So it gives you a little bit of a tolerance to fall within. So you have 4, 5, 6, 7. So you have about 7/10 that you can fall within in order to give it the proper fit that it's supposed to have for the bearing to go in there. The way that I was told is that on these end bells, even though it might seem like a press fit, they're not actually supposed to be a press fit. I mean, they should push in with a little bit of resistance, but not a press fit. And one of the reasonings behind that is that whenever this thing gets up to operating temperature, the thermal expansion gives it the proper fit once it warms up, and then it's actually pushed against this board right here. So anyway, this is just one of my charts right there. I got another one that I use at work that's actually, it says for electric motor housing and shaft fits. I'm going to get a measurement inside this end bell just to kind of see where we're at on sizing using my telescope gauge. And so our maximum was going to be 2.8353. 8353. And right there I'm getting 836. So we're well over the maximum on the tolerance there, so we know we need to bore it for our sleeve. So what I've done, and this is usually what I do on an end bell, I don't want to go all the way to that shoulder, but what I do is I bring the tool in there and I touch it, and then I set an indicator over here on this side, and I move it back an 1/8 of an inch. So we're gonna give it an 1/8 of an inch before that shoulder is where we'll stop at. I'll start with a 50 thou cut. We're only gonna be taking a 1/4 inch out of this, but I like to just see how it's gonna react. Yeah, it's got one of those steel inserts in there. That's how a lot of end bells were made, like this. And you can clearly see the steel insert in there. And hopefully that's going to be thin enough. It looks like it is, but thin enough so that will clean that completely up so that we can put our sleeve in there. Go ahead and get a measurement. So we should only be about 100 thou over. Yeah. Okay. There you go. Take a look at that so you can see it before we cut it all out of there. There's the steel insert. All right. ahead and finish this thing up. Starting to get into some cavities that's casted inside this thing. I'm looking through, it's not breaking through on this outside or on the back side of it there. It just looks like it's a void inside the casting there. We're just about there, and because of the thickness of this, I'm not going to go that full press fit that they recommended. I'm gonna only give this thing 2 thousandths. It said 3.081 is recommended. I'm miking it at 3 inches, 85 thousandths. So we're gonna make this 3.083 and give it 2 thousandths press fit. All right, this should have been our size to where we want it. Let's go ahead and double check it. Very good, we're right there. I want to put a little chamfer right there and polish that board, make sure there's no fuzzies in there that's going to bind up. And then we'll take it out of there and press the sleeve in. Alright, so we're going to take this out, we're going to go to the press and press the sleeve in there. And once we're done, we'll just come back and then we're going to re-indicate this thing. And then we'll finish the bore. There's a little bit of oil trapped down in there. I want to clean that out, so I'm going to use my CRC heavy duty degreaser. I'll just go down there and blow it out real good and wipe it, and that should be pretty good stuff right there. Leaves no residue and evaporates quickly. I'm going to give my arbor press a try to get this in there. So we got that cleaned out. I've also cleaned the sleeve itself with the degreaser, and I'm going to put a little bit of my 680 Loctite on this just to help. That's an adhesive, so it'll bond in there and it should not come out. 680 is actually for a slip fit. This is where I use this a lot for slip fits there, but it'll still work. It's just the 609, which is for a press fit, is a little bit thinner. All right, so I'm just going to put a little bit in there. It ain't going to take much. I'm just going to put a little bit like that, and then I'll rub it around. Just a drop more right there. You just want to make sure that whenever you're using any kind of Loctite product like this, that it's covered well on the two mating surfaces there. Okay, I'm going to put a little bit on the sleeve also. Just rub it all the way around, make sure it's covered real good. All right, and hopefully we'll have a good successful press right here. Felt nice and tight going in there. And I feel good about having the Loctite there too. That'll create a very strong bond between the two metals. And that thing will never come out of there unless you heat it up and cut it out of there. All right. Alrighty, let's get it bolted back up. Okay, I've got the Brown & Sharp Best Test indicator set up on what's left of this face here to check it. I'll just stick it on 15 there, and let's see how close it is. Remember, I had it originally within about 2,000 square. So it looks like that's 1, 15, it's 1.5 thousandths. That's within 1 thousandths right there. These two seem to be the, try it again, it's 15. That's about 1 thousandths. I'm gonna leave it where it's at. I mean, it's pretty good. It pulled right back up. But we need to go ahead and make sure that we're in the center now, so I need to do some indicating there. We might go ahead and go back to this edge right here and make sure that this part of the housing is in the center. All right, to make my job easier, I'm going back to my Starrett 670 attachment. We should be able to clear everything and just make sure. Yep. Okay. All right, well, we need to make a little bit of an adjustment here. That's tight. I'm going to work opposite jaws. We just want to make sure that the opposing jaws are about even as you can get it. So that's about 2 thousandths right there, 2 or 3, depending on where that needle stops. I'm just trying to move it over that way instead of having to loosen it. All right, so that's pretty close right there. That's about 0, 0. So we'll go to the other two jaws. So that is -3, and that's -5, so about 2 thousandths. So we'll go to our low and see if we can push it. So we're going to call that's -4, -4.5, -4. Well, that one jumped. Depends on where it lands right there. We're going to call that center. That should be good to go. Now I am going to take the test indicator. I'm going to check this face one more time off camera, make sure that it didn't move with this indicating we just did. So to bore out this cast iron sleeve, I'm going to be using a TPG insert. This is a TPG 431. These are excellent inserts and tools to use to machine cast iron, cast and bronze. These things really shine, and I've got lots of these inserts. I've had plenty, and I've had plenty that people have given me. So I love this insert when finishing these end bells. That's about right. We got about 50, 55. Got her zeroed out. I'm going to slow my feed rate down. Use about a 5,000th feed rate to clean this up. We'll start with 20 thou. You just want to get rid of the dust whenever you're going to get in there and check the bore. Alright, so that took 15 out of it. Alright, so we're going to have 35, about 40 thousandths to come out. I've got exactly 21 thousandths that I want to bring it to size. So we are going to do a 10 thousandths cut here. And then I'm going to sneak up on the size. Exactly 10 thou. We're at 824. 824 and 5/10. So 824, and what we want is, we want 834 and 6/10. So now I'm going to do 5 thousandths. We'll do 2 cuts. We're going to do 5 thousandths, and then whatever else we need is what we'll take on our last cut, and then I'll back out the tool so it don't drag on the way back out. You got to really make sure that you're reading your lines right whenever you get down to these final movements. Half a line could throw you off. Here we go. We're going to do a couple measurements, and we'll dial in our final cut. 831 exactly. We are at 831. 831, 834 and a half, so 234, so that's 3.5 thousandths. 3.5 thousandths. Now I'm going to set me an indicator over here on the cross slide at a 0, just in case I need to go back in there and it didn't cut it to the size. Let's hope that we did get it to size. Alright, there's our 0. Cleaning up that little bit in the back. Alright, we're going to retract the tool. Now let's give it a check. Alright, we're at 834. Let's see where our tenths end up. It's going to be close. Alright, there's our touch. 834 and 4/10. Alright, so I'm 2/10 under the minimum. And that's what I always shoot for, is the minimum size. Just because we all know you can't put it back in there unless you just redo the thing. What I can do is very easily hit that with some 220, and it should take a 10th out easy as soon as you touch it, because it's going to remove the high spots of the tool marks. Just giving another check there, touching. 4/10. All right, 834 and 4/10. So we're there. We're right where we need to be. So what we need to do now, let's go ahead and clean this face up right here. I'm going to slow it down a little bit. Let's see if it'll handle it all at one time. No, it ain't going to like it. There's just not enough rigidity in that part right there. So what we'll do is we'll just face it. I'll use a facing tool and go across there. We'll try that carbide tool right there and see how that works. come in here and touch the aluminum. All right, there we go. We are going to take this tool out, put my chamfering tool back in there, and put a little bevel on the start edge. Okay. All right, so here's the part everybody's gonna give me a lot of hard times over. Polishing out the bore. Five tenths. So I got a tenth out of it. So I just need to do this a little bit more. Just like I said, I'm just using some 220. I hold it like that so that it doesn't pull it out of my fingers, and just use my index finger there. Push down on it. Just like so. And there we have it. We hit our 834 and 6/10 on the mic. I'm gonna leave it right where it's at. That is a good fit on the minimum size required for that housing there. There's our brand new bearing, SKF 6207. Feels like money. I can tell that the fit is right there where it needs to be. It's trying to go in there, but you got to get it perfectly aligned, perfectly straight, and then once you do get it straight, it'll push in there with some resistance. So I'm not going to get it stuck in there, but I just do that because I know that it's on size. If you bore that thing over, which is a sickening feeling, if you bore that thing 1/1000th over what you're supposed to, the bearing will just fall in there, and you can't leave it like that because that's what you're trying to correct, is a loose fit. So this is going to be good right here. All right, awesome. So I'm going to do the other one just like you see me do right here. I'm not going to video it because it's going to be identical process. All right, so I'm going to go ahead and knock that one out, and then I'll come back and we'll see both of these finished, and then after that we're going to move on to the rotor. I just wanted to show you this. This is the second end bell. I wanted to go ahead and mic that bore. I wanted to see how much oversize it was, and where I mic'd it, where the worst wear is, it's 5/1000ths over what it should be. And I've got the new bearing stuck in there, and you can see just how loose this is. See that rock? If you look down there, you can see there's a step in there. It's probably hard to see, but there's a step. So this is what tears up your electric motors if these fits aren't right. This will help contribute to the damage anyway. So it's important these things are on the right size so that that bearing fits in there right and it's not moving around. All right guys, both of the end bells are done and ready to go. So this is the one that I just did that I didn't film, this one here, and then this is the one that you did see film, and both of them turned out good on size. I'll show you this one like I did the other one right there. I can get it started down in there. I can feel it starting to go. So, all right, this phase is done. And so now what we're gonna do, next video anyway, and we're gonna start on this rotor shaft right here. So I mic'd this end right here. This is the one I wasn't sure if it was good, but this is bad. It's actually not round. So if you mic it in one place, it's showing that it's right on the minimum, and then if you turn it and mic it again, it's going to be about 1/1000th under. So this is a bad fit. And of course this side is a bad fit right here. This is 5/1000ths under the minimum right there. So I mean, it's just flopping around right there on that side. That's why there's so much movement going on. So this will be the next series up, or the next video anyway, and I plan to do my spray welding technique to repair these, and hopefully you'll tune in and check that out. So I'll probably start on that very soon. And anyway, I hope you guys have been enjoying the videos, and come on back for some more, okay? We'll see you next time.